Okay, thank you for showing up today. I'm glad we actually got people to join us. I didn't know, it was really short notice, and I was just I'm working from home in Volda, and sometimes I go to Oslo. And this time I had something to say, or I wanted to say something, and then I was just looking for if the room was free, and it was, and I decided to do this. So I hope you find it interesting. Both my talk and Marco's later were both Ignite talks at Configuration Management Camp in Ghent in Belgium in February, which is a really nice conference for people that specialize in configuration management. And it's quite interesting because all the different tool vendors are there, and the conversations that happen are, to me at least, more interesting than the ones that are at the vendor-specific conferences, because we talk about problems in general and how to solve them, and all the tooling have similar problems and similar benefits. So it becomes a really good environment for talking about real things instead of just listening to the vendors. So you should go there next year if it happens. I think it will. My lightning talk first. Yes. No. Okay. This is my handle on Twitter, and you should, if you use Twitter, you should try and bother me there, because I'm quite active and try to. I'm using it as a tool for things like this and to learn things, and it works really great for that. I try to be friendly, and this is a story about a project I was on just recently, and I have no left, but this is some of it. So the problem was we were a team of 5 to 10 people, and I didn't say this in Belgium, but our task was to automate and deliver OpenStack. So it's quite an interesting task. It's both development, infrastructure, hardware, network, everything, and you have to have knowledge in all those areas to be able to do that. So we had a code base that started in 2014, and we were building it to try and create a modern and fully automated data center-wide system that used mainly Puppet and then other tooling to manage it all. And then I mean all. The idea was that the only thing that we should get externally was a pipe with internet. So all the things that all the code that were in that system should be managed by Puppet or other tooling. So everything was fine for a while. About a year in, we started to see that we had some problems. Yeah, when we started, we were thinking that we had, because we were all quite experienced, we had good progress, and we set up CI and used automated testing. We used patterns that we already had used before with success, and we went fine. But then when we started actually doing production, it became apparent that we had some problems. When we started onboarding people, or the process was, we had a QA environment, and it became over time more like production, and that was the plan too, because we wanted a group of people to stay in the QA environment in order to verify it, and those had a different SLA or had different quality of service than the other ones that were in the real production environment. But it didn't work really well. It took too long time. Whenever we did a change, or whenever we wanted to isolate a change in order to test it properly, we needed to rebuild things from scratch in order to test it before it got into QA. So the environment before QA, we called it test, but it was partly dev too. But the test environment, in the test environment, we couldn't recreate what we needed in order to simulate the changes we were doing. And it was just too slow, and it didn't work. And it turned out that we had dependencies that crossed the environments we had set up. So we call that leaking environments, and it's really bad to do that if you want to develop an infrastructure. And I'm a bit shameful to admit that was actually happening, but it was. And the reason was mostly because it took so long. It took too long to simulate the changes or the environments that we needed in order to do proper testing, that people were taking shortcuts. So whenever I wasn't looking, somebody, I will just do this. So what actually happened was that some people started moving nodes from one environment to another one without saying anything about that. And then, if you know about, most people don't write code in configuration management that can go both ways. You can most of the time only go forward, which is kind of logical. It's a best practice to not design for rollback, actually. But if you start moving nodes across the environment, then you have some unknowns that you, after in a while, will hit you. So that was happening, and yeah, we had to do something. We had several occasions where we, because of this leakage and because of we didn't control the dependencies good enough, where we would stop a service, do an upgrade, and start it, and it would fail, and we had no idea why it failed. Because we thought we were doing everything right, and yeah. So we could say that we had eventually reproducible systems, which is better than not being able to reproduce them at all. But when reproducing something in order to verify it takes too long time, people get annoyed. And a long time is a relative definition, but if it's more than, say, 1 minute or 2 minutes, then most of the time that's too long. Because if you're doing testing of something, you need to have a feedback loop to yourself and your teams that are quick. If you don't do that, they will take shortcuts, or at least ask to try and do them, which is not what you want. So we had to admit that what we were doing was wrong. It wasn't working. It wasn't fast enough. It didn't scale to the amount of changes that we needed to do. And it had worked before, because then what we were doing, or our experience, was that if you have a single system with a limited set of dependencies, like, for example, a database server, an application server, and a front end, then those three are pretty much isolated, and you can control that environment. But with OpenStack, it's so big, and there are so many dependencies that it becomes a task in itself to just manage that, and you have to do it in a different way. So yeah, you are doing something wrong. People told us. Yeah, that was obvious, but what? Well, we tried different approaches. One thing that hit us with this was that we saw that we hadn't controlled our inputs well enough. What I mean by that is, for example, we were CentOS based. So when you install and deploy CentOS, most of the time you're using yum repos. And one really common shortcut that you do is that you don't mirror, or you don't control the inputs that you get from your repositories. You should really think about trying to manage all your inputs or all your repositories and have them on disk and build from that. If you're not doing that, then you will hit problems. And yeah, I'll just stop there. So we tried using, and there's a product from Red Hat, or there's a project which is open source that is called Pulp, which is like a repository manager. It's similar to other artifact or repository management systems, but it's specifically geared towards software repositories like Yum or other repositories you need. But it was too much, because that is another full system in itself, and you need like a cluster and a database, and just in order to do that. So yeah, we didn't even manage to do that. But maybe. So one of the things people said, you should be using Docker. And then Docker came and saved us. Well, no, it didn't happen that way. We searched Docker, and for our use cases, we saw that it could be used for some things. But the interesting thing was that parts of the ideas from Docker were, in our minds, universally applicable. So some of the tooling and some of the ideas that the people that are saying you should use Docker for everything, some of those are actually good and actually doable in more realistic scenario too. So, so this solution became, and this is hyperbole again, we stopped doing configuration management. So, and because when you think about configuration management, or people that have experience with configuration management and Puppet and CF Engine or Chef or Ansible. Ansible is the new one that's really bad now, because if you're using Ansible, you think you should use it for everything and it's going to save the world. Well, and that becomes like your prime mindset, that configuration management is going to solve everything. It's not that simple. So we need a way to try and attack all the complexity we had built in the code base, and the fact that it was managing so many different separate parts of a full infrastructure. So what we did was we removed the notion of a central configuration management system. So we took that away. We stopped using Puppet Master. We stopped using a central Git repo that contained everything, because that becomes just too much. And that's why I'm putting here that doing configuration management, which we actually didn't stop using, but we used it in a different way. So what happened was that the complexity went away or reduced, was reduced, because the amount of code you needed to review and look through in order to do a change to one role or one part of the infrastructure became less. Because when you deploy, for example, Ansible or Puppet, most of the time people create a large control repo that's supposed to be like the authoritative source of all the code that you're using. But when you do that, you take, in a way, you can say that you take away the responsibility of the applications to actually enter, or the APIs of the applications become under something that lies below that level. And you say, I'm going to configure everything and handle all the dependencies and version all the APIs and control all of that. And that then the control repository that has all that becomes a bottleneck for changes. And so, yeah. This is what we did instead. It's very simple, and it's so simple that it's a bit hard to see what I'm talking about. But we try to change our thinking from configuration management into thinking about artifacts, which is even closer to software development, I guess, than we were previously. So this is actually a way of describing what we're doing using Packer. So the great thing about Packer, and I really, really love all the HashiCorp tooling. The great thing with Packer is that it's, and when people think about it, most of the time they are thinking about it as a tool for creating images, but that's not the best part of it. The best part of it is that it's a pipeline tool. So what it means is I can build an image, but the most important part is when I've done that, I can feed it back to the same process. So I can do multiple build steps and produce artifacts at each stage. And if you start handling those artifacts as your deliverable instead of the monolithic big control repo with all your code, then the world becomes more manageable, at least in my experience. So what are those? Inputs are typically also managed as artifacts. They could be repos, packages, images, containers, whatever. The really great thing with Packer is that if you model a workflow with it, then what you build for becomes a configuration setting. So as an example, I can, in the same process and with the same tooling, I could build a VM, or I could build a Docker image or a container image. And this is all done with the same tooling and in the same workflow. And actually, if the service or the application you're deploying is suited for it, you can build an image that will be a VM, and then build a container image using the exact same code base. And that's quite interesting to me, at least. It means that when I choose, I can build a VM artifact, and if I want to change my process and instead deploy a container, I can use the exact same code and have a container output. And the change. So input, and then the next step in the pipeline is the change. And this is where I cheated. I said we weren't using configuration management tooling anymore, but we weren't running it centrally in like a monolithic fashion. We were running it inside the package tool chain to do the changes to the artifact that we needed. So producing an output. And then the output, of course, at the end of the tool chain. And the key to the output handling is, of course, to version it. And that means that, for example, in my limited small example with a DB, an application server, and a front end, you could possibly version the front end artifacts, because that's what the front end does. And then you, instead of versioning everything together, you do it by role or by system or whatever suits you. So abstraction is key. If you want to help people understand why you're doing something, you need to show them the theory behind why you are doing it. So when I talk to my team about why we were going to stop using configuration management, I show them that simple input, pipe, change, pipe, output. And even if that's a really, really simple thing, having that in mind at all times is helpful, because then if you have the same abstractions, it's a lot easier to talk about the same things and to understand each other. So these are some more definitions we made. A chain like the one on top, we call that a project. And again, a project is something that we version in Git. So instead of having one single monolithic big control repo with submodules to all the other stuff, the new way of doing it was having a project in Git that was producing an output. And another thing that's really key to doing this is that you get, it's easier to think about testing and how we can use other methods or already established software development practices on your infrastructure if your artifacts are testable. So when you have a VM and that's a description of how you produce it, you can test that. And it becomes really, it's not hard to think about multiple ways of testing it and verifying that it's correct. So this is another definition. Instead of doing configuration management, we were trying to describe state to produce artifacts. So it's the same thing, but it's different. And again, keeping that state from drifting. But as I said, we didn't stop doing everything we did before. We could reuse some of the things we had in the more or bigger monolithic approach. Of course, all these projects we made in Git, they had some dependencies too, because and there, again, the DB application server and front end, those were a system. And a system would consist of one or a number of roles, and a role consists again of a number of profiles. And profiles to us was the first implementation layer. So in order to make an implementation, we would take like the base profile and then the database profile and put them together, and that would be a role, for example. yeah, another thing when doing this is think about managing state, because if you are building VMs and those are your artifacts, it also changes how you think about systems, because part of this is, of course, when you upgrade a VM, you replace it, which means that everything that was inside it is gone. So you have to think about that and how you arrange, for example, storage or database clusters or whatever data you are going to keep. You need to keep on persistent storage or in somewhere that isn't affected by the provisioning process. So that's quite a difference from doing more monolithic or long-lived systems. Yeah. Another thing is that when you're doing this, you would possibly want to also deploy some form of service discovery with it, because the state that you define doesn't contain the live or runtime information you need. So it becomes, when you configure something, you have to decide, is this value, is it a part of my static configuration or my build configuration, or is it a part of something that has a runtime state? For example, how many nodes are in my cluster, or which node is the master node and which ones are the slave nodes, for example. You can't build that into an artifact. The artifact you build will be slave or master, but you don't know that until it's deployed. So, yeah. Okay. One of the most successful changes that you can do, I think, and now this is quite common, at least in the Puppet configuration community, is to separate code from data. And it's a lot harder to do than it sounds like, because even with Puppet and Hyra, which was probably the first one that tried to do this for configuration management in a good way, is that when you do it, you start to take for granted that it's Puppet that's going to read the data. And when you do that, your data becomes less valuable, because yeah, how should I explain that? You probably know why. If the data you have to describe your system is dependent on the configuration management tool, then your separation isn't complete or correct, in my opinion, at least. So yeah, it's really easy to write too much things or too much data in JSON or YAML, and you think that, oh, I'm not going to use this for anything else than Puppet or anything else than Ansible. And then the next thing you see is that you need another system to read that, and then you start reading it, and the data is garbage because there is some comma in there, and that's for Puppet. So yeah, try and be aware of this, and especially for people using Hyra. Don't think that Hyra, if you need to duplicate data in YAML with Hyra across nodes, it's not an anti-pattern to do that. Most people try and create, like, or I've seen people try and create really, really complex YAML-based hierarchies that they query to solve like any query possible from the data they have to describe, like locations and roles and systems. It's a lot of value with trying to simplify the management of data and instead write tools on top of that. So, for example, if you're going to change a password, instead of having one, what I'm saying, you should try and generate, for complex operations, you should try and generate the YAML from external tooling and just write it to disk and have it be an authoritative source of information, configuration information, instead of trying to have the tooling be smart. Yeah. Okay, that's in fact the reference there on that slide is from a new project that's supposed to be configuration tooling or independent of what tool you are using, It's still early, but it's a data layer that you use to deliver all variable data to your tooling. So right now I'm trying, or I've written a proof of concept where I can use the same YAML base to drive Packer. Then I have to rewrite it into JSON because JSON is the native data format for Packer. But I use the same source for both runs of Packer and runs of Puppet, and also for test inspect testing, because with inspect it's a Ruby testing suite where I can use the same tooling as in Puppet and read from the same YAML store, as long as the data isn't Puppet specific. Yeah. So does this work? So I'm trying to sum up what I've been talking about. We tried using container-like workflows and tooling to help reduce some of the complexity we were seeing when we had a really large monolithic configuration system that was central, and everything had to go through it, and all the changes had to go through it. And does it work to try and cache configuration management runs into artifacts? They are, when I produce an image that has done parts of my needed configurations already, that's in a way you can say that's a cache of your desired state. So yeah, it did work. We could actually rebuild systems a lot faster, and and this was only because of the fact that we didn't have to configure everything from scratch. But that's just part of the game. So, for example, we had a build or I don't know, and there's we have had a concept of node sets. And one of the more complicated systems that was in a node set took about 35 minutes to build in order to verify change. And when we did this and we pre-built all the images and just only rebuilt the ones that were affected by the actual code change, we could reduce that to like 7 or 8 minutes. And that was about, I think it was 12 VMs needed to simulate that system. Yeah. And this is more about what tooling we were using to do that. So I had questions about Terraform, and we were not using Terraform for production, so just relax. And that's, some people are doing that already, and you can do that even with OpenStack, for example, as the backend. But we were only using it for testing, because the strong point of using images or containers with Terraform is bringing them up. But trying to maintain state with Terraform over time is not something I would do yet, maybe in the future. And also there we have the fact that we stopped using Puppet Masters, and we used RPMs, in fact, to deliver all the code onto the node that needed it instead of asking for it over the network. Yeah, and then again, the single configuration store. And this is kind of a joke, but when I left the team, we weren't at that stage yet, but the idea is that to stop doing YUM upgrade at all, and whenever there's an upgrade, you rebuild the VM and deploy that again. Okay. Any questions? Thank you. Yeah, sure. Oh, yeah. The question was if we considered looking at Nix OS. Of course. Oh, the Nix package. Have you tried using that in CentOS? I've dreamed about doing that in CentOS. Yeah, exactly. But the thing is, I don't want to build all my software from scratch. I want to choose what software to get from a vendor or a distribution and then build on top of that. Because in my experience, that gives me more for less work. So in my example, in the team I left, it was OpenStack that was the goal to deliver. And with OpenStack, you would want to have libvirt and all the KVM stuff delivered from the distribution, and then build whatever you needed on top of that, most likely, which is Python code and different whatever you needed. It would possibly be, it would be interesting to try and do that with Nix, but I don't think it's ready to do, or to put it this way, I think maybe if the Nix developers had, instead of creating an OS, would have created a software distribution layer or a package system that could live on any operating system, I think they would have had quicker. Because it's possible to do that. You only need a C compiler. Yeah, that's my take. Yeah. Yeah. Excuse me. Yes. Yes. Okay. Yeah. Sure. Yeah. That's a big question. The question was, if I give up configuration management and don't run it centrally all the time, how can I check or verify the state of all the nodes? Well, part of that is, I don't know, have you been following the immutable dream? So what you can do is, for example, to answer the question first, it's not true that we didn't run configuration management. We ran it on the nodes after deployment in audit mode to see if it changed. So with all the tooling currently, I think you can do audit modes, different audit modes. For example, with CF Engine or with Puppet. With Puppet, you can just dash no up. I mean, it won't change anything, but it will still do the report and everything. So yeah, I think part of that need, or the it's like none of my engineers would change anything in production anyway. They knew they would know that that's not something you do. And if you think about that, then it becomes a question about what files are possible to, if you're talking about files, what files are possible to change once the VM is deployed, right? So if you think about that, then you might be thinking about how could you run the kernel as a read-only mostly system, and then your question becomes what services are running when, and how do you? So yeah, what I want to do is, if I get to work with this kind of infrastructure in my current job, is to look into what I need to run something like an embedded Linux type system. I know that you can configure the kernel to be more like an embedded kernel, which means that you will know in front in the configuration of the kernel where it can write and actually change things, and everything else will be read-only. And then whenever you start an application, you could pull in the configuration values you need from your, most likely I would be using console to pull the data that's the runtime configuration, and then start the application in with a read-only disk for the application code. And thus, to me, that's interesting because I think that improves security, and it becomes impossible to change any of the binaries, for example. So yeah, is that answer? Is that an answer? So the real answer was we didn't stop running configuration management, but we stopped doing it from a central code base. The code that configured a node was living or on, so maskless Puppet, basically. Yeah. Any other questions before I hand over presentation to the next? Have anybody not that are not on AWS been considering doing image-based deployments. I know Windows people are doing it, pre-baking images with configuration. No, okay, you should try if you think it sounds interesting. Yeah, okay, I think I'm ready. I'm done. I think Marco will introduce himself, so I'll just try and switch. You have? Okay. Okay. Just not close too much windows. People are leaving. No. Okay. I'm not sure if you will. I can try and do yeah, mirror. Yes. Yes, I'll try that. Mirror. I will continue. Now I think we need to do it full screen first. Don't need that. Close. And then enter full screen. Oh. Okay. And, well, if we do the desktop one, it might work. I think it is running now. Hmm. Okay, I need to click there. Okay, nice. And then you can try.
I guess people on the Hangout were enjoying some interesting noise. Let's see. Oh, well, can you see I love Macintosh? So what kind of key I'm supposed to press now? Oh, thank you. Goodbye. Yeah, that works. So thank you for staying since the others just went away. Yeah, 3 or maybe 4 legs of modern configuration management. Before we start, just checking for surprises. Who's using configuration management of you? Raise your hands. Okay, so there is actually someone not doing that. Okay, but that's okay. Let's see how many are using Puppet, for example. How many are using Puppet with something else like Ansible? Okay, yeah. We're going to talk about that kind of things. So about me, since I know that my last name is a pain in the ass for everyone to pronounce, everyone that's not Italian is Maronjus, and I try to help Norwegians and English speakers. This is my blog, if you're interested. I work for Opera. This is my Twitter call sign. I come from Sardinia. Now, since Nordic people seem to have some problems identifying Sardinia in the Italian map, and they asked me if we put horse heads in the beds of people or make offers that people can't refuse. No, that's the wrong island. The island is that one on the left. Okay, it's not Sicily. That's another thing. But I don't take it as an offense. But okay, so 3 legs or 4 legs of modern configuration management. There was quite a lot of talking at the configuration management camp this year. A lot of presentation were basically venting out a lot of dissatisfaction about how configuration management is today. It seems that the tools that we have been using until today are not doing their job anymore. They cannot really help us more. I kind of agree. And well, I mean, if there was this presentation at an Ignite talk and at least one presentation talking about a possible 4th generation language, talks about using Puppet with Ansible. And even a guy from Red Hat, James Shubin, also known as Purple Idea in Twitter, showing a proof of concept of a new configuration management tool that implemented some of the things that people were longing to, like, for example, parallel execution. Then you may really think that we are in the wrong place today. How did we get there? Let's start a short journey and see if you see yourself there. So there was a time where configuration management tools were designed to be proactive, which means they were designed to check the state of your system at well-defined time intervals and correct any deviation from the desired states. CF Engine was designed like that. Puppet was designed like that. Anything that differed from that approach came as an afterthought, but the design of the tool was that. So the proactive tools were like that, and eventually people started to suffer because, for example, with this kind of tools, it's really difficult to implement things like, let's say, remote execution. You want to run a certain set of commands or certain set of configurations on a subset of your machines now, and implementing that with this kind of tools was, let's say, a bit impractical. So someone said, well, scrap it. I will start doing something different. So shit configuration management, proactive tools, and people started to design on-demand tools. So I apply my desired state when I want it, on the nodes I want it, and I don't care about proactive approaches. Well, it solved a different category of problems. But eventually it was not enough, again, because in the so-called elastic infrastructures where nodes are created and disappear quickly, like you have containers or virtual machines coming up to cope with a sudden excess of load, and then after 3 minutes they are gone. None of these approaches was fast enough. You can't just stay there and type commands trying to cope to stay just behind. You're always behind. So people started to design different tools that check the environment around, like with fleet awareness, so-called. So checking the state of the environment and change the configuration of the system, you could say reactively. Yeah, it was this kind of tools, you know. You change the configuration depending on the environment or against the environment. Well, you choose. Okay, so we have proactive, we have reactive, we have on-demand. Was that enough? Well, since some of you, for example, said, I'm using Puppet and Ansible, guess what? It was not enough, because as I just said, each of these type of configuration management tools solves very well certain categories of problems, but not all. So people started to hybridate. So using, as we said, Puppet with Ansible, and you have examples of CF Engine with Salt, and you use your configuration management tools to install console so that you can also use adaptive or reactive and so on. You have all the possible combination of this stuff. Okay, now it's enough. No, it's not. Otherwise, how comes that people start to add to all their things shared distributed key value stores, for example? Or how comes that people are trying to enlarge the scope of their configuration management tools by creating, for example, a service bus and passing around information and events using a service bus? So people are starting to write codes on their own to complement the configuration management tools. We are at that point again that we have started to make our own tools instead of using something that is there. That's fantastic. What does that mean to you? To me, it means that our configuration management is old. Basically, none of the tools that we have today is modern enough for the type of problems that we have today, at least. If you have a limited set of problems, then you can be still okay with one of those. But if you have like a broad infrastructure, very different types of problems to solve, then it may be that one single tool doesn't help you enough. And there is more. These proactive, reactive, and adaptive are the three legs that people should start thinking of. If we start today to build a new configuration management tool, we should actually build something that implements those three approaches in a single place. Because if we keep on using different tools, we have all sorts of side effects and all sorts of side problems. For example, one thing that we may want to do is to partition where each system touches things. Otherwise, we may have, let's say, Puppet and Ansible competing for the configuration of a certain configuration file and stepping on each other's toes each time you run one or the other, which is pretty bad. But there are also containers today. And someone says, if you use containers, you don't need configuration management. Well, it may be true if you have a very short-sighted concept of configuration management. Because some people use this configuration management just to install packages, deploy configuration files, that kind of stuff, and that's all. Well, I have bad news for you. You are doing provisioning. You are not doing configuration management. There are more things that are part of configuration management, like managing processes. People should try to remember that a configuration management tool, for example, helps you keep, let's say, SSHD and rsyslogd up on your machine when the out-of-memory killer kicks in and decides that you don't need SSHD anymore, for example. So you can actually manage processes. To make just one more complex example, we had an application that we needed, and a colleague put it together very quickly, like in a few nights when he finished work. And we found out that this, to run well, this application should have no less than 46 threads. Because if there were less threads than 46, something was broken, but the application was completely silent. Like, for example, it lost the connection to a database or something else. But it was running. So we had to write a CF Engine policy to check how many threads were there, and if they were less than 46, restart, please. So you can actually manage processes with configuration management. You can manage services. But you are on a single node, usually. Otherwise, you would not need to have a distributed value store to try to share information across an infrastructure, right? Well, to me, containers and containers orchestration is the next step. You are actually, it's like orchestrating processes, but your boundary is not a single machine anymore, it's an entire infrastructure. And orchestrating containers and orchestrating virtual machines across an infrastructure, to me, looks like the next configuration management, not the end of configuration management. So these are the 4 legs: proactive, reactive, adaptive, proactive, reactive, and on-demand, and we need to orchestrate containers. We need to have shared information, so fleet awareness, if you want to call it fleet awareness, which could be, again, key value stores, sharing events so that machines across your infrastructure are aware of what's happening around and react accordingly, and so on. There is a presentation from configuration management. It's called Time for a Fourth Generation Language, and it was by Walter Heck. And he collected a number of features that people want from configuration management, and configuration management is lacking. Parallel execution was one of the features that was cried for. So you can also take a look at his presentation. The slides are available to see how many of your current problems are actually more people's problem. The important thing, is that we stop being stupid, basically. One example that Luke Kennis, the founder of Puppet, did last year in a panel at Configuration Management Camp was to say, we don't do like scientists that use the results of other people to build something more. We just had something, scrapped, did something else, scrapped, did something else. How much can we progress this way? Very little. And in fact, we are more or less back to the situation we were in 10, 15 years ago. So I don't know what the next configuration management tool will be. I don't know in what language it will be written. I don't know if it will be written around Kubernetes. I have no idea. But if we don't try to do things in a sensible way, we won't get really far. And that's it. Thank you. Yes, questions?
Would you say that might be that part of the problem trying to move forward is that most of the people that have developed view on this might actually current communication tooling. So and they are because of that. I think I might have three, so it means that there is a limit for resources. But part of your all needs for this course first, and then they are I'm not sure.
Okay. To summarize your question is, if people are too bound to any of the existing products, it may be impossible to get to something else. Of course, I have my personal opinion, which you may agree or disagree. I see myself as a CF Engine power user, which may be wrong or right. I don't know. You judge. Anyway, I'm suffering from all the syndromes I described here, and I can tell you that if a tool that implements all the things I need without all the headaches that sometimes I have with CF Engine, I would probably take the time to explore and possibly replace it, which of course is not like it's not happening in a snap. When I switched from Puppet to CF Engine, it didn't take one day. It took a few months. But in the end, I did it, even if I had invested something, because I was really, let's say, annoyed by Puppet. And I would do that again. I don't agree with the fact that people won't probably change because they are too bound with an existing solution. Actually, my idea is that if someone comes with something modern today that is barely acceptable, like it implements all the things that people need in a at least acceptable quality, level of quality, then all the vendors of the existing vendors, configuration management vendors, will start to have problems. That's my idea, which of course didn't, I expressed it in writing, and of course Luke Hennis wasn't really happy. You know, for those who don't know Luke, he's quite frank when he expresses his opinion, and he basically said that what I wrote was shit, and he said it twice. So, sorry, when? No, this year. A few weeks ago, yeah, and yeah, if you look at syslog.me, you will find it because it's quite recent. Yeah. No. Okay, the question is if they are defending. I don't think so. The point is any of the tools that we use today have started with certain design, which probably was okay when they started designing it. And then they started building on that design and improving that design. And it's fine, but there is no way that they can continue to evolve that old design and get something that we can use efficiently today. That's my opinion. The point where Luke Hennis was actually quite upset against me was, in his opinion, I was saying that they were not innovating. I can say that all the vendors have done innovation. The problem is they have done innovation starting from something that is old today. Even if it's not old, because Ansible is not old at all, right? Yeah. So that's what I'm saying. I would be very happy if any of the existing vendors start redesigning things from scratch and implementing all that we need. I don't want the existing vendors to disappear, but I fear that if they don't do this step instead of evolving from an old pattern, that's probably what's going to happen. Yes. I've seen a few I've seen a demo of Kubernetes at the Day of Docker in Oslo. I've read something. I think they are doing wonderful things. What I would say, because of for lack of a better knowledge, is they are solving again a very well-bounded problem, because they can do wonderful things with containers, but bare metal is not going away. Virtual machines are not going away. Maybe there will be more people using containers and less people working on big iron infrastructures where these things will run. That's not only Google, it's Rackspace, it's Microsoft, it's, how's it called, that one? The IBM thing, well, whatever, SoftLayer. Yeah, you have many. But what does it mean? It means that those people shouldn't have different tooling that solves their problems. You know what I mean? Kubernetes is not going to provision their iron servers. Yes and no. That's what we are here for, to discuss these kind of things. Yeah. Did I answer, or? I'll count to 300 and then we can, oh, okay, I'll count to 3. Any more? Yes? If I said that the future is in one single configuration management tool, I would be rather stupid. Oh, it's unbelievable. But I'd like to see vendors building their tools. How can I say that? Looking at all these paradigms, maybe more. I know that they have invested a lot in their code base, in their current code base, and it's a pain to say, well, okay, let's keep it going and start something completely new. I would just shake in my bed if I was in them, right? But I think it's what's necessary, what is necessary. If there was like a CF Engine 4, a Puppet 10, a Chef 200, whatever, that's what people are needing. And then, no, I'm not betting a single cent that they will do something together or they will like have the same, share the same language. Not betting on that, but it would be at least nice, let's say. I don't want to use stronger words. It would be nice if they consider implementing all the approaches that they have just discarded and more. Two, three. Thank you. Oh, I tried with, yeah. Yeah.